In this question it says a wooden crate is pushed across a concrete floor at 5 meters per second. So let's visualize it. So let us say this is a concrete floor and this is a wooden crate and it is pushed at 5 meters per second. So it slides to a stop after moving a short distance. So let us say it comes to rest here. So now the speed is 0 meters per second and the distance moved is d. And during this time it slowed down to rest because there was a retarding force due to friction. So let us call that as kinetic friction. So this is case 1. So let us call it F1. And we know F1 is mu k times normal reaction, which will be mu k times mg, where m is the mass of this block. Now if it is filled so that it is weighing twice as much, so in case 2 the same crate has a mass of 2m. So let us say this is case 2, and again it has the same initial velocity, and again it comes to rest, so 0 meters per second. So the distance would be, let us say, x. We need to find x. So now what would be the friction force? Again it will be opposing, let us call it F2. So coefficient of kinetic friction only depends on the pair of surfaces, so it will be same, and normal reaction would be different now. It will be 2m times g because the new weight is 2mg. Now we will use work energy theorem, which says that sum of work done by all the forces is equal to change in kinetic energy. So in case 1, change in kinetic energy is half m v square minus u square, so 0 minus 5 square. And that will be equal to work done, which is going to be negative because friction is opposite to the left and the displacement is to the right. So it will be angle between force of friction and displacement is 180 degrees. So cos 180 is minus 1. So work done by friction is negative. It will be minus mu k mg into d. Now for case 2, change in kinetic energy is half into 2m into v square minus u squared, which is equal to minus mu k into 2mg into x. Now half m into 0 minus 5 square is present here also, and that is supposed to be minus mu k mgd. So replacing it, minus mu k mgd into 2 is equal to minus mu k mgx into 2. So 2 mu k mg will cancel out, minus will also cancel out, you are left with x equals d. That's why your correct answer is supposed to be C, which is same distance. So to understand it from physics point of view, why the distance traveled comes out to be same is, see, in order to move the heavier object and make it come to rest in the same distance, you need to exert extra force. So that extra force is the friction force, and friction force increases in proportion to the weight. So heavier the object, more the friction force, and heavier the object, more the force required to accelerate it by same amount, and that is what is happening. Okay, now let's look at the second question. A team of skydivers jumps from a plane and holds hands to form a flower-like design. As the skydivers begin their free fall, their velocity increases and their acceleration decreases. See, the acceleration decreases because initially the acceleration is just due to the weight, which is mg, because acceleration is net force by mass. Initially net force was mg at the time when they are just released, okay, and they are at rest. But then As the velocity increases, the drag force due to air resistance also increases. So the faster and faster the people fall down, more the air resistance. So slowly the air resistance will start increasing. So let us call it as friction. So the net force will start decreasing like this, like this, like this, like this. Finally, the net force will become zero, and that is the stage when terminal velocity will be reached. So all the while, when the net force is decreasing, acceleration is a non-zero positive value, and so it keeps on speeding up. But finally, when the acceleration becomes zero, when net force becomes zero, whatever is the final velocity at that stage, that remains constant after that, which is called the terminal velocity. So acceleration is decreasing the moment the object starts to fall. So that's why the correct answer is B.